Hello all. So in the previous video, we have seen how to draw the board outline, right? That is the first step when you are starting with your PCB because you want to know the PCB dimension. The second step is you have to set up something in your PCB such that your manufacturer will get to know what to do with the Gerber files that you have received. So as a part of that process, the first step is to define the stack up. So stack up actually defines the number of layers and your dielectric constant, and then what is the solder mask. So all related settings will be part of the um, stack up. Now we will see how to edit the stack up details or where to see the stack up details in your KiCad PCB file. So in order to see that, go here, okay, and click on edit board, and it opens up your board setup options. So in these options we can actually edit whatever you require in order to set up your initial PCB settings, especially from the stacker perspective. But before going there, one of the important thing, when you have drawn the board outline, on the left you see there are number of layers which will be little scary if you are starting. Okay, so we can actually use only what we want, especially on the top side and the bottom side. So top actually is indicated by F, bottom is actually indicated by B here. Okay, so now let us click on the board setup. It takes little bit of time to open that. So here, right, you will have all the options. The first thing, we will not be having any user defined layer for this, so eliminate these here. Okay, eliminate all the user defined settings, user drawings, user comments. We are not going to use any of these. If required, we will talk later. And then we will also be not providing any fab instructions. Eliminate that. We will not be using any adhesives. You can eliminate that as well. And you will have the courtyard is the space around the component. You will have the paste on the bottom side as well as the top side. You will also have the seal screen is required, masking is required, and copper is required on the top and the bottom. So you can see here, these are the signal layers where we will route the signals, because we are planning to go for a two-layer PCB. So we just have two layers here, signal, and both of them are signal. We don't have any plane. So you can also actually provide a power plane if required, but we are going for a signal layer here. And then there is something called physical stack up under board stack up. Okay, here you can see, luckily this particular setup is done for two layers, and this is a simple RISC-V board that we have been designing, right? So this is not impedance controlled. So we have two copper layers only, top and bottom, and already the dielectric is mentioned as FR4 and its thickness is 1.51. The actual board thickness is 1.6 mm. So if you want, you can adjust here. You can see here the copper on top of it is around 0.035 mm. This is the top copper, this is the bottom copper. There is a core in between. So because it's a two layer, we use a core. And then on the top and the bottom we have mask, solder mask, which will be there, and there is a solder paste that has to be applied for soldering, and then seal screen. So this all comprises the stack up. Now we can also change the epsilon r here if required. So we are actually using epsilon r of 4.5, the delta constant. For now we'll keep it. This is not neither a high speed design nor any critical traces are present. This is a simple RISC-V microcontroller board that we have designed, right? So we will actually keep it. So based on your requirement, you might have to vary this, and this actually is enough for you to start with the two-layer PCB. So board finish, so copper finish, actually you can see whatever you want, whether you want ENIG or immersion gold, you can actually specify. And if you don't want to specify, not specify, default one will be provided by the PCB manufacturer. In case if you are not aware, you can talk to them and get the details. And for now, all these settings, text settings, design rules, everything will keep as is. So here you can see here, copper to copper spacing. You have to get to know about your PCB manufacturer. You have to approach them and get the clearance and trace with the capabilities of your manufacturer, and then you might have to come back and adjust here, because minimum clearance 0 is not actually acceptable. At least generally, every manufacturer will be able to have a clearance of 6 mil where they can actually able to manufacture. Okay, so you get information from your manufacturer and fill these details.